going to look into exploring microservices with gRPC. Microservices simply speaks about an architectural design where your application is thought of as a coming together or an interoperability of services to make your app work perfectly fine. A little bit about myself. My name is Bayo Opesanya. I lead the backend engineering at AO. I don't know if any of you has used AO. If you have, you may have used my bugs. I'm sorry. I'm also the country director for Node.js Nigeria, and I love music. I forgot to add that I'm bowed, and I'm happy that nobody raised the red flag. All right, so what is microservice? What is a microservice? Now, in case you've been curious about what it is or how it works, now you're not alone because this is the trend of Google searches on the subject of microservices, right? So people have been asking, and you can see from 2014, it's been going all the way up to 2019. All right, so microservices, also known as microservice architecture, is an architectural style that structures an application as a collection of software services or services that are highly maintainable and testable. So it means that every component of your application should be highly maintainable and highly testable. It also means that they are loosely coupled, so every part basically doesn't depend on the other one to work. So for example, if you have an application where there are two different services, the services should not exactly depend on one another to work. All right, independently deployable, you should be able to deploy each service as a separate instance on itself, and it should be managed as a separate instance. As regards, in case you want to change something in that service, you don't have to restart your entire app just because you changed something in one service. It's supposed to be organized around business capabilities, and it's supposed to be owned by a small team. Now, a perfect example of this I will give is, I don't know if you remember at one point in time, where on WhatsApp, you could send messages, but you couldn't send pictures or videos, right? What most likely, I don't know, but what most likely would have happened is that the particular service that handled media was having issues, right? But you could still use WhatsApp. You could still send text messages. Now, if it was not in the microservice architecture, for example, what would have happened is the whole of WhatsApp would have been down, no voice notes, nothing, no SMSs, you can't do anything, you can't call, because what? Because a video service is down. And I would say opposite of a microservice is a monolith application. So imagine you had a video sharing application and you want to split it into microservices. You most likely have an upload service, a streaming service, a transcode service, a download service, a recommendation service, and a subscription service. So for example, if something is wrong with your subscription service, your whole app is not down, right? People can still upload stuff, people can still stream. It just means that subscriptions will not work at the moment. Now, how do services communicate? Usually, the way services communicate right now is you make HTTP calls, right? You make a call to an API, HTTP 1.1, right? But I will explain in this talk why that may not be the best and why I think connecting your services with gRPC may actually be what works for you if you want to consider using a microservice architecture. All right, so gRPC. Why gRPC? Or first, let me say, what is gRPC? So gRPC is a high-performance, open-source, universal RPC framework by Google. Now, it is not Google RPC. It is actually gRPC remote procedure calls. It's not Google RPC. If you heard it was Google RPC, it's a lie. All right, so why gRPC? gRPC is based on what we call HTTP 2. Now, HTTP 1.1 is what we are used to, right? You make a call to a certain API. Now, I did a demo on this site. You can do it as well, http2demo.io. Right, what happens is HTTP2 is a lot faster. So you can see I actually ran this demo on my laptop. It's just that there's no time, I'll run it here too. This is actually about 200. This one image you see here is made up of about 200 images. This is also made up of about 200 images. And when I ran a HTTP1 test, normal HTTP1, it took about 5.44 seconds. When I used HTTP2, it was 0.87 seconds. Now, this is very fast. Like, imagine the time difference. And I heard a lot of feedback about, for those that use AO, one of the things I heard the most is, it is fast. They say, yeah, AO is very fast. You send to someone and boom, the money is there already. This is part of why, because a lot of our services communicate with gRPC. So gRPC is faster. And also, wow, this is so heavy. It's lighter than and faster than text-based protocols. Now, the way your normal APIs communicate is what? JSON, right? Or XML. The issue is those are text-based and they are heavy. And with your HTTP request, you still have to pass headers as well. That's a lot of text. Now, if you're using gRPC, you use a certain communication protocol called proto, like protocol buffers, basically, or for short proto. And what protos do is they pass your messages across in binary format, right? So that's much quicker to pass and much faster. You get, and that's another reason to use gRPC. Now, I would have done a demo as well, right? I would have shown you an actual application where what I did was I built basically a small app and I converted from a monolith app into a microservice. And then what I did eventually was I sort of split the app into services. So there was a service that handled authentication. There was another service that handled things like sending emails or sending push notifications. But we are out of time, so I will not be able to do that. Because I like to be quick. This is the end of my talk. You can follow me on Twitter at 1JSNinja. You can also find me on GitHub as well. Right? And if you have any questions, I'll be happy to answer maybe after. I actually may have something for you, right, if you have questions. So you can stop by, like you can just stop me. But for the next speaker to come up, I'll have to end it here. You can find me on Twitter and GitHub, 1JSNinja. Thank you very much for having me. It was good to be here. A great audience. Have a great day.